So in this example, I want to show you how to simplify expressions using rational exponents. And remember, rational exponents are just fractional exponents. So you should have read the text before looking at this example video to see what radicals have to do with rational exponents, because the two are directly related, and we're going to use that fact in this example. So I have two examples here, part A and B, so let's start with part A. So before I begin this problem, notice it says to simplify, but then we're going to write the answer using the same notation as the original. So since the original problem here was given using radicals, we're going to write our answer using radicals. Over here, we're given a problem with rational exponents, so in the answer it will have rational exponents. Okay, so part A, I'm going to work this from the inside out. I have layers of radicals here. On the innermost section I have x to the 36th power, and I'm taking the fourth root. So I'm not doing anything with this cube root right now, so I still have that layer to tackle later. For now, I'm going to focus on this part right here. Okay, so x to the 36th, if I'm taking the fourth root of that, I can rewrite it as x to the 36th over 4. However, because this is an even power, if x was negative, an even power would eliminate that. And I can't take even roots of negatives, right? So I need to factor in this absolute value here. Okay, so 36 divided by 4. 4 actually divides in, does it divide in evenly? So 4 actually divides into 36 evenly. So this is the cube root of the absolute value of x raised to the 9th power. So now I just pretty much repeat the same step, but now I'm working with the last layer of the problem, this cube root. So the cube root of the absolute value of x raised to the 9th power is the absolute value of x raised to the power 9 over 3. And 9 over 3 is just 3. So this is equivalent to the absolute value of x cubed. Okay, so in the second example over here, I'm going to be working with fractional exponents. So remember I said that the way we wrote the answer had to match the original because that's what the directions told us to do. Because this division worked out evenly and then again worked out evenly, I don't have anything remaining inside a radical, which means this is an appropriate form for my answer. If I still had some x factors left inside of the cube root, I would need to make sure to use radical notation for that. Okay, moving on to part B. We are now going to work with fractional exponents from the start. So you can see in the numerator and denominator separately, things have been simplified. There's no parentheses, a single x, a single y in the numerator, single x, single y in the denominator. So what I need to do is combine them across this division bar. So I'm going to use one of our properties of exponents, any kind of exponent. And since these two have a base of x, I can combine them together by taking the difference of the two exponents. So 1/5 minus negative 3/5. And I can do the same thing with the two y terms. So I have y negative 2/3 minus 1 for the exponent. So remember that in order to add or subtract fractions, you must have a common denominator. All right, so on the x term here in the exponent, we see they both have a denominator of 5, so we're all set there. But we don't have common denominators here. So what I'll do is I'll simplify this x term right now, and then I'll simplify the y term in a second, because we're going to need to find common denominators. So this minus minus turns into a plus. When you have those common denominators and you are adding or subtracting, you keep the common denominator. So again, this is plus, so 1 plus 3 is 4. And then I'll copy this term down here. Okay, so I need common denominators. One of these is already a fraction with denominator 3, so I'm going to do some side work here. I want to combine negative 2/3 and I want to subtract 1. So I'll go ahead for the common denominator 3, so I'll multiply 1 by 3 over 3. I get negative 2 over 3 minus 3 over 3, and now I can actually combine these together. Again, common denominator stays. Negative 2 minus 3 is a negative 5. Okay, so we'll have x to the 4/5 and y to the negative 5 over 3. Do not use mixed fractions in your exponents. Do not make this negative 1 2/3. Okay, this needs to be negative 5/3. Okay, in the instructions, it didn't say anything about needing to use positive exponents, but I'm going to go ahead and do that anyway, because I see that I have a negative exponent here. So in order to take care of that, I would have x to the 4/5, that one's already positive, over y to the 5/3, just to show you that extra step.